Welcome, ladies and gentlemen, to another edition of Binary Life, a channel that teaches new developers how to code by solving algorithm problems so that you can see how the solution is thought about. Today, we're going to be solving how many unique consonants are there. So, if you are new to the channel, don't forget to subscribe. This channel is really about coding and helping beginners know how to code. So this problem is linked to the problem I solved in the video I did just before this one. I'm going to put the link in the description or somewhere on the screen so that you can click and see that algorithm talks about how to count the number of consonants. So we're going to use that algorithm and modify it to adapt it to the solution of this problem here. So let's go to train and let's try to read the problem to understand. So complete the function that counts the number of unique consonants. Consonants are letters that are used in English that is different from this. These are vowels here actually. Everything else in the alphabet, it's a consonant. Alright, remember your function needs to return the number of unique consonants. What does it mean unique? It means if we're giving something like this, add. In add here, there is one vowel, which is A. So how many consonants are left? There are 2. But since it's duplicate, they said unique, so we just have to count one of the D. So the answer here should be 1. I see the answer should be 1. Okay, similarly, the function should also disregard duplicates. Like for example, this is dad here. Dad, is one vowel, I forgot about it. There we have D and D. So it still counts at 1, even though the one is capital, one is lowercase. So that's basically it. So I'm going to bring the solution. I'll copy paste the solution I did in the how to count the number of consonants in general, and then we'll modify it for this particular problem. All right, so let's copy this. I'm copying and bringing up. All right, so I'm going to paste the code here. Okay, I want to make it orderly. Right, I'm going to increase the character of the screen. So what does this algorithm do? Basically, we have everything that is not a vowel, so no vowels, this is it here. And then we initialize the number of consonants to 0. I'm just going to call this I'm going to make it more friendly. So this is all consonants. So I have a variable that stores all the consonants that are available. Let's replace it here. So these are all the consonants of the English language, and then this I want to count the number of consonants here, so I initialize it to 0. So now I loop through the string that was given as a parameter here, and split it so that it becomes like an array. So that I can loop through every character. So I loop through that string, every character of that string. So our loop, that's why our looping variable is car. And then I check if inside all of these consonants that the character is included inside. I even lower the case so that I can take care of lower and uppercase. So basically, if our character is inside all consonants, it means that I increase my consonant counts. I can make this shorter like this. Is the same thing, and then I return the consonant. So this algorithm just return the number of consonants, but it doesn't return the number of unique consonants. I think it also takes care of that capital lowercase thing here. So I'm going to modify it so that we can have a lowercase. And for me, the solution I have right now in mind is to track, which means I'm going to create a tracking consonant variable here. I'm going to put it in the form of an array. Oops, sorry about that. All right. So basically I want to be tracking the consonants and storing inside here so that I can eliminate duplicates. That's what I want to do. So as I split this string, as I'm looping through, if I need a consonant, let me comment this. If I meet a consonant, I want to take it and put it inside tracking. So before putting inside tracking, I'm going to check if the consonant is already inside here. So there will be another if here. If this tracking guy here includes, or let me negate it like this, negate with the exclamation sign. If it doesn't include our character, because here we enter this if it's a consonant, the next phase we're going to check if it is not inside the tracking variable here. If it's not inside, then we can now put inside. This is, we want to eliminate duplicates. If it's not inside, then we're going to push it inside here. So I'm going to go like this, and I'm going to push the character. That's it. I don't need this. I'm going to just leave it like that, and I'm going to comment this. So at the end of the day, let's console log our tracking variable to see how many unique consonants it has tracked at this point. Just console log it, and I'm going to also console log the initial string that was given so that we can see the difference. Yeah, I'm going to console log the initial string. Right, so let's come out of the full screen, and let's reduce our character size. Alright, so now let's test the code. So our initial string is a sillystring. So how many tracking consonants we have here? We have S, we have one S, so it has been unique. It hasn't taken into consideration the double S. We have one L, one Y, one T, R, and G. This sounds like it's already correct. Which means after tracking, which means I just have to return, the algorithm says how many. I just have to return the size of this array here. So I just have to return the tracking consonants dot length. If I test the code, this is what we get, and I'm going to remove this consonant count. I don't need to count it anymore because our tracking consonant does that for us. I can remove this, and I can remove the console logs to make the code cleaner. That's it. And let's test one more time to see that we haven't broken everything, and then we can attempt the code. It fails for one particular, for some cases. We have 5 failed tests, so I am going to bring back the console log so that we can track that and see what's going on. So this is the fail case here. I think it's the capital scenario. We have the capital C and minor C. Alright. Because when it enters the tracking here, at this particular 7th line, it checks if it's already inside. It wouldn't. The capital C will be there already. The small c we think is different. What I can do is I can just basically check. I can just include inside the tracking here just the lowercase version of the character, because here we can see that the tracking consonant has uppercase. I can just include the lowercase. I can just put in the lowercase version inside here. So I'm going to push this character and put just the lowercase inside there. And while checking, also I'm going to check if the tracking variable also doesn't have the lowercase version also, so that we can just be dealing with lowercase. And so let's attempt this. This should be okay. And let's attempt for the global, so it passes the test, and it passes all the tests. I can remove this. So the key is really the lowercase for this our particular algorithm. So let's attempt the solution and submit, and so that we can see what other people have done. There's always somebody that does something that is interesting to learn. So he transformed the whole string into a set. This is crazy. This is actually wise, because the sets remove duplicate characters, if I remember very well. Let's test that. So if I open the node console here, and I have a particular string to be test string here, what if I put a set let's just call it my set to be equal to a new set, and inside I'm going to put my string. And if I will display this, you can see that it has removed duplicates. The string is test string, so it has removed the T here. And then what else has it removed? It has removed this second S here. There are two S here. So instead of test string, we have test ring. So that is why this thing is important. He removes duplicate automatically. So we are just left with one character each, and then we can now test to see if we can just count the number of consonants. Basically, we can just count the number of consonants, and that is what it does with it. So first of all, he converts a string into lowercase, and then he replaces everything that is not, this is a regular expression. He replaces everything that is not, I think this should be not, I think so. Everything that is not between A and Z, that's I think we remove special characters. Everything that is not a special character, or this bar is for or. Everything that is not a vowel, let's remove it, let's replace with an empty string, basically. So after all this filtering, we are going to be left with just consonants, and then we're going to be left with a set of consonants. Remember, this is a set. All of this takes place inside a set. So, and then we just return the size of that set. This is basically very wise. I think it's the same solution here. This is the same solution, just inverse. So everything that replace everything that is not a consonant with the empty string, and then bring the size. That's it. So I think all of this is the same thing, and this is somebody that took the time to break it down like us, step after step, and checking and stuff like that. And that's it. This is his tracking variable here. Number of consonants. No, here, consonants. It's a tracking string. We had an array, but this is a string for him. That's it. And then he also counts. Meanwhile, he could just return also the length of consonants. So it's the same thing with just one extra variable, number of consonants that he can do without that. So I'm going to stop here, and that will be it. But we can come back to our algorithm and get some inspiration from there. So let's try to refactor this. I know we can also use regular expression, but I want to bring back and this works already. Let me bring back the initial algorithm the way it was before. In the beginning, when I was just counting bare number of vowels here, just counting the number of vowels here. So what I can do is, if I transform this to a set, normally this should work. So if I say this is my set, it's equal to new set string. If I do all of this to a set, let's just test that and see if it works like this. What do we have? I don't know what, because I don't know if we can split the set, something like that. Let's see this like this. I can just look through a set without splitting. It works for some particular thing. Well, I won't go into the details. I just wanted to try something. So let's stick to the initial algorithm so I don't waste more time here, because we already have a solution. So this is our solution, and I just wanted to do a test. And thanks for viewing, and don't forget to subscribe. Multiple and hundreds of algorithms will be coming, so in one way or the other you are going to learn something. And thanks for watching again. See you.